Hi folks, it's Liz Strong here. I'm back with a homework demo video from Unit 2. Our very first homework demo from Unit 2. Can you believe we're already there? Yay, I say. Again, I hope you've read your lessons and are now watching the video, and then when we're done, you'll be ready to go do your homework. Let's get started. So, here is my real number system. Today, we need to learn the different types of numbers that we have and how to categorize different numbers. So we start out with all the numbers, almost all the numbers in the world. I think it's kind of odd that I have to tell you that there are some numbers in the world that are not on this number line that you've never heard of. They're called imaginary numbers. But every number that you have ever heard of is on this number line. We'll talk about imaginary numbers much later on in algebra. You don't have to worry about them right now. The only numbers you know are on this number line. They're on here because the number line goes forever in both directions, right? This arrow and this arrow tell you the number line doesn't stop. It keeps on going. If I need to point out some numbers to you, then I will say this. I would put a little dot on the number that I wanted you to recognize, and I would say this number line now represents the number -6. No biggie, right? If I wanted to represent a number that was not sitting already written on the number line, I'd give it a little mark and I'd pop it in. 1.5 goes about right there, right? So numbers that are not listed on this number line are here even though they're not listed. I hope you recognize that. But there's lots of numbers between these numbers and they're not on here, but they're here. So numbers like the square root of 3. Isn't that funny? The square root of 3 is on here. It's a funny number. It's a number that's a little less than 4. And the reason I know it's a little less than, oops, I put it in the wrong place. I better start again. I love when I make mistakes because you're not going to make them later on. Let me start it this way. I'm going to put the square root of 4 on here, and that'll keep me from messing up. Square root of 4 goes right here. And we know it goes there because the square root of 4 is 2 times 2. And there's 2 inside, so we bring 1 out. Square root of 4 is really the number 2, so it goes right there. Well, if the square root of 4 is here at 2, then the square root of 3 is right before it. So I can kind of decide where weird square root numbers go just by knowing what's after them or before them. Another example would be 9 is the square root of 81. So where would the square root of 87 be? Well, it's somewhere about right here. I don't know exactly. I'd have to get out my calculator to find out exactly. But it's 9 point something because I'd have to be all the way up to the square root of 100 to get to 10. So I know that the square root of 82, 83, 84, all the way to the square root of 99 are all in between 9 and 10. I hope that makes sense. Okay, so we need to be able to name all these different categories of numbers that you see down here. We've already done the real numbers. Real numbers are every single number you have ever heard of. The only numbers that aren't real are these goofballs called imaginary numbers. We'll talk about them later. Natural numbers. I sometimes call the natural numbers, and not just me, lots of people, call them counting numbers. If that helps you remember any, to realize that the natural numbers are just simply the numbers 1, 2, 3, 4, 5, like that. Easy, right? Well, it's easy, except I need that list to keep going. So I do this to it to show you it keeps going. I put it in a little set with brackets. That's a bracket, and I don't make them so great. And then I put 3 dots right there to tell you that this set needs to keep going. But it needs to include every natural number that exists, all the natural numbers. And they're all those numbers, we call them counting numbers. Whole numbers are easy too. Watch this. They're just like the natural numbers, except they have a 0 in them. That's the only difference. They keep going forever, just like the natural numbers. They just include a 0. So if I ask you, is 0 a natural number? You say no. Is it a whole number? Yes. Is it a real number? Yes. So numbers can be more than one thing. All numbers are real. Sometimes they're whole. Sometimes they're natural. sometimes they're integers. Watch this set and see if you can figure out what integers are. I'm going to start it with 3 little dots, saying it goes on and on and on in that direction, the negative direction. And it has -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. So another way to describe integers, and by the way, integers are really the most important number on here. You really need to understand that integer means positive and negative whole numbers. It basically is all the numbers that you see written here. Positive and negative whole numbers, those are our integers. And we can write the whole set by putting little dots at each end and by listing just positive and negative whole numbers inside. Also a good time to point out, by the way, 0 is the only number that appears on the number line just one time. And it's the only number that's neither positive nor negative. It's just 0. So we never put a positive or a negative sign in front of it. So rational and irrational is where we need to go next. And I made these two guys a different color because they kind of go together, and also because all numbers are either rational or irrational. That's not the, you can't say that about all the other groups, but all numbers are either one or the other. They're either rational or irrational, and it's pretty easy to decide which. Here's how you do it. Irrational numbers are weirdos that go off and they're weird decimals like 0.763298, like it keeps going, and we don't know where it goes. We can't predict what comes next. It behaves irrationally. These numbers come from square roots that aren't perfect, is the way to put it. Root 3 is irrational. Root 99 is irrational. Root 15 is irrational. But, watch this one, root 4 is a rational number because it's really equal to 2. So be careful with the roots that are perfect. So here's the deal. You have to decide all the time, is a number rational or irrational? And you ask yourself first, is it irrational? Because the only irrational numbers in the whole world ever that exist are these numbers, decimals that go on and don't have a pattern, and then square roots that aren't perfect. So if it's not an imperfect square root and it's not a weird decimal that goes on then without a pattern, then it must be rational. Because those guys are the only irrational. And I keep saying without a pattern, so let me show you this one. Something like 2.22222, it goes on forever, but it's rational because we can tell what comes next. It behaves rationally. All fractions are rational. If it's a fraction, then it is rational. The only thing that's irrational are weirdo square roots. I know I keep saying that, but it's so important. And pi. Pi is a weirdo, kind of like a weirdo square root. It really is, but we'll call it pi right now. 3.14159, and then it keeps going, but it doesn't repeat itself, and we can't really tell what comes next. So, irrational, I've written in yellow, or I've tried to highlight in yellow. They're not as difficult as you think. If it's not irrational, then it must be rational. We're going to look at some more examples. And then real numbers, everything's a real number. All the numbers you've ever heard of. Okay, I know it seems like a lot, but it's really pretty straightforward. Let's practice a bit on this next slide. Well, maybe. There we go. Okay, so here I've drawn a Venn diagram. Here's the way it works. The white part back here is like the number line. It's all the numbers in the whole wide world. And inside that, there are some numbers that are irrational. And we've already decided that those are things like pi and 31 and 0.7632, or maybe even 5.7632, 198. It could even be negative 5.76. It just doesn't keep going, but it doesn't behave rationally. Those are all irrational numbers. Over here, on the other side, it's a little bit difficult, but actually I should back up and say, see how you have to choose first? Is it rational or irrational? All real numbers are one or the other. then once we know it's rational, we have to start thinking, but is it an integer? Because all the integers are inside the rational numbers. In other words, think about that number line. If all the numbers on the number line are real, and then all of them except these guys are rational, then integers are also rational. And we start having to name things as more than one. They want you to name sometimes all the categories that a number belongs to. Most of the time, you're interested in the most specific category it belongs to, the one that tells the most about it. So let's put in a few more examples here. A rational number could be something like 2.7676, and it goes on and on forever, and it's negative. Or it could be positive, 3.582, and it goes on. Not an integer, these two things I just wrote up, so I can't put them into the integer column. So I'll put something else in there. How about -3 and 0 and 5? Those numbers can all go into my little integer spot. They are integers, and they're also rational, and they're also real, because all numbers are real. Whole numbers are cool because the only number that goes in here is the number 0. The reason is the number 1 is a natural number, so it has to go the most inside. And so does 2, and so does 3, and all the other whole numbers. So it's 1, 2, and 3 are natural. 0 is a whole number, it's an integer, it's rational, and it's real. So let's look at another slide, play around with it a bit, and we'll start categorizing all these different kinds of numbers. I hope it's not horrible yet. I think it's pretty straightforward. So you're given a number like, say, -5, and you are asked to name all the categories that -5 belongs to. Well, you first say, I know it's a real number, and then you say, okay, well, where does it belong in this little guy? Well, I see -5 right here in the integers. And it's an integer because it's a negative whole number. So that tells me that it's real, and see how the integer circle is inside the rational circle? So it's real, it's rational, and it's an integer. So if you were asked to name all the categories it belong to, you would say real, rational, and integer. But if you were asked for the most specific category, then you want the most inside one, and in this case, it's integer. Let's try one more. How about root 17? Is root 17 a real number? Yes, all numbers are real numbers. Is root 17 rational? No, root 17 is not a rational number. If I put it in the calculator, it's going to give me this weird decimal answer. So it's irrational. And once I know that it's irrational, he's over here in this spot, and he can't possibly be natural or whole or an integer or rational. So once he's irrational, we're kind of done. Let's try one more. Let's do the number 0 because it's one that seems to muck you up a bit. The number 0. And notice again, I always start on the outside, the biggest category. It's real. All numbers are real. Then I start working in by deciding, is it rational or irrational? As I check off the opposite ones I say, sorry. Well, 0 is rational, isn't it? Makes a lot of sense. It is not irrational. Is it an integer? Yes. Integers are positive and negative whole numbers and 0. So yes, right there in the integers. It's an integer. Is it a whole number? Yeah, and it's sitting right there in the whole number box, isn't it? So it's a whole number. Is it a natural number? Nope, it's not. It's a whole number. Stops right there. 0 is not part of the natural numbers. I hope that you will not have too much difficulty playing with these, and I hope that you will hang on to these slides. Don't forget you can save my slides and refer back to them later. This is one more, just the same thing, only a little bit different that I put up just to show in a different way. This time, all the irrational numbers are down here. So there's the irrationals, and here are the rationals. Notice they're separated. You can't be both rational and irrational. You have to be one or the other. Also notice that we have these two blocks are both inside the real numbers. So if you're rational or irrational, you're going to be real too. Once you decide something is rational, then you have to start deciding, is it an integer? Is it a whole number? Is it a natural number? And I hope this little guy will help you out with that. I think you're ready to go do your homework. Are you feeling ready to go do your homework? I hope so. One more little box, just leaving it here, not even going to talk about it. Very same concept. I just put it up in different ways to help different people that think differently. So go get your homework done. See if you can categorize the different types of numbers. Don't forget to use these slides to help you out if you need it. I will see you in class next time. Take care.